Yes, hello students. Last class video naga equation of a line in space adrolaga equation of a line through a given point and parallel to the given vector nodidvi. Correct? So today's class I will take up with the next derivation, that is equation of a line passing through two given points here. Okay, so previous olaga one given point which is parallel to one vector antidda. So here what you have, equation of a line passing through two given points. So what are the two given points here? One is A with x1, y1, z1 coordinates. One more point is B with the coordinates x2, y2 and z2. So there are two coordinates here. A ಮತ್ತು B ಎರಡು ಪಾಯಿಂಟ್ ಇದಾವ. Okay, vector A is what? It is position vector of point A, and vector B is what? It is position vector of point B. And this OP is what we have represented by R vector. It is the position vector with respect to the origin. So this is your diagram. So how we are going to represent it? Let A and B be 2 points, okay, of the vectors of what points? A point x1, y1, z1, B point x2, y2, z2. So I write here A is one vector, okay, A is one vector with the points what? We have taken the points with respect to what? A, x1, y1, z1. Okay, then I take up the next one, that is B. B vector is for the point B, x2, y2, z2. So how many points are there here? There are 3 points. Okay, A vector with respect to x1, y1, z1 and B vector with respect to x2, y2, z2. 3 coordinates because this is 3 dimensional. A and B ಎರಡು points ತಗೊಂಡೇನೆ. Okay, next what I have to do? I have to take one position vector. That position vector I have represented it by R. R is what? Position vector. Okay, so of what point here? R is a position vector of the point P, of the point P, X, Y, Z. Okay, now we know that P is a point on the line if and only if AP, if you write AP ಬರಿಬೇಕಂದ್ರೆ ಏನಾಗ್ತದ? You want this distance, so this will be equal to what? R minus A. AP is equal to R minus A. Then from A to this point AB, AB will be equal to what? B minus A. Okay, I have written now AP, this is equal to what? Position vector R minus position vector A. Then the line AB, if you want from A to B, then it will be vector B minus vector A. So these two are what? Collinear vectors. Collinear andre ena? All three should lie on the same plane, same space here. A, P, B. All 3 points are lying on the same line. Okay, so these are what? Collinear vectors. So we can write now, ನಿನ್ನೆ ಈಕ್ವೇಶನ್ ಒಳಗೆ ಏನು ಬರ್ದಿದ್ರಿ? ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು A times lambda B ಅಂತ ಬರ್ದಿದ್ರಿ. ಕರೆಕ್ಟ್? ಸೊ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ವಾಟ್ ಯು ಹ್ಯಾಡ್ ರಿಟನ್? A plus lambda times of B. This is what you had written for a given point. Same thing you are going to write here, but what it becomes here? R minus A is equal to lambda times B minus A. Why? Because there are 2 points here. So R minus A is equal to lambda times of B minus A. So what will be the position vector? R is equal to what? A plus lambda times of B minus A. Okay, so R minus A is equal to what? Lambda times of B minus A. A ikkade shift madidre A plus lambda times of B minus A. So this is a equation of a line passing through two given points. So first what you have to write? You have to write A vector with respect to the point A, B vector with respect to the point B, and R is a vector for an arbitrary point P. Then we write AP is equal to R minus A, AB is equal to B minus A. Then comparing these two, if they are collinear vectors, then R minus A will be equal to lambda times of B minus A. R is equal to A plus lambda times of B minus A. Very important. Find the equation of a line passing through two given points. ಎರಡು ಪಾಯಿಂಟ್ಸ್ ಕೊಡ್ತಾರೆ ನಿಮ್ಗೆ, ಎದು ಬಿದು ಎರಡು ಪಾಯಿಂಟ್ಸ್ ಕೊಟ್ಟಾಗ ನೀವು ವೆಕ್ಟರ್ ಇಕ್ವೇಶನ್ ಬರಿಬೇಕಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಯುಟಿಲೈಸ್ ದಿಸ್ ಫಾರ್ಮುಲಾ. R is equal to A plus lambda times of B minus A. So remember this derivation as well as the standard equation. Okay. Now the same thing we have to write it in Cartesian form. The same what we had done yesterday. So yesterday's class we had derived it in both vector form as well as in Cartesian form. Now also we are going to derive it in Cartesian form. Okay. So now derivation from Cartesian form. Cartesian form you have to derive it. Sorry, derivation to Cartesian form. From which form you are deriving it? From vector form. Okay. To derive this, you know now R is equal to A times B minus A times of lambda. Okay, R is equal to A plus lambda times of B minus A. Now I need to know what is A, what is B and what is R. If I know all these three values, R value, A value, B value, ಮೂರು ಗೊತ್ತಿದ್ರೆ ನಾನು ಈ ಇಕ್ವೇಶನ್ ಒಳಗೆ ಏನು ಮಾಡ್ತೀನಿ, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ equation na vector form convert ಮಾಡ್ತೀನಿ. So first thing I should know all these three things. What is R, what is A and what is B. Okay. So first thing you all know what is R. R is equal to what? It is xi plus yj plus zk. Okay. Standard position vector, the standard form xi, yj, zk. Okay. What about A and B? A and B are two vectors with respect to point what? A is with respect to the point x1, y1, z1 and B vector is with respect to the point B, x2, y2, z2. So ಈ points respect ಅದ ಅಂದ್ರ ಇದನ್ನ x1i plus y1j plus z1k. B vector is equal to x2i plus y2j plus z2k. So all three I know now. R value gottada, A value gottada, B value gottada. So substituting all these three in this equation number 1. So R is equal to, R value another xi plus yj plus zk is equal to, what is A value? x1i plus y1j plus z1k plus B minus A I have to write. Okay. So B minus A andra x2i B value plus y2j plus z2k minus A value is what? x1i plus y1j plus z1k. B minus A. Lambda I write it here. Okay. So R value is equal to A plus lambda times of B minus A. Okay. So now I have to keep it R this side only. xi plus yj plus zk as it is I keep here. Okay. So this is equal to here x1i plus y1j plus z1k plus. So this will be x2 minus x1 into I. Lambda is outside the bracket. y2 minus y1 into j plus z2 minus z1 into k. Okay, so you get now x1 xi plus yj plus zk is equal to x1i plus y1j plus z1k plus lambda times of x2 minus x1 into I, y2 minus y1 into j, z2 minus z1 into k. Okay, now these three terms, if I take it this side, what it becomes? X minus x1 into I plus y minus y1 into j plus z minus z1 into k. Okay, so ಏನು ಮಾಡಿದೆ ಈಗ ಇವ ಟರ್ಮ್ಸ್ x1 y1 z1 ನ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದೆ. ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡಿದ್ರೆ I ಕೋಎಫಿಷಿಯಂಟ್ ಸೇಮ್ ಆಯ್ತು. ಸೊ x ಮೈನಸ್ x1 ಆಯ್ತು. ಇದೆರಡು ಕಂಪೇರ್ ಮಾಡಿದಾಗ y ಮೈನಸ್ y1 ಇಂಟು j, z ಮೈನಸ್ z1 ಇಂಟು k. So this is equal to, I write lambda into bracket x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. Okay, now the next part is very simple. You have to compare the coefficients. I with I coefficient you have to compare, j with j coefficient and k with k coefficients. So after comparison, so lambda value first one compare ಮಾಡಿದಾಗ x minus x1 is equal to lambda times of x2 minus x1. Y minus y1 is equal to lambda times of y2 minus y1. Okay, next z minus z1 is equal to lambda times of z2 minus z1 on comparing. Okay, on comparing you get x minus x1 is equal to x2 minus x1, y minus y1 is equal to lambda times y2 minus y1, z minus z1 is equal to lambda times of z2 minus z1. So lambda is equal to what it becomes? X minus x1 divided by x2 minus x1. So this is equal to y minus y1 divided by y2 minus y1. This is equal to z minus z1 divided by z2 minus z1. So this is the vector form of a derivation. Okay, so I repeat it now. First thing ಏನು ಮಾಡಬೇಕಾ, r is equal to a plus b minus times of lambda ತಗೋಬೇಕು. This is from the previous derivation. That is what equation of a line passing through two given points. ಸೊ ಇದ್ರೊಳಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕಂದ್ರೆ ನಿಮ್ಗೆ ಆರ್ ಎ ಬಿ ಮೂರು ವ್ಯಾಲ್ಯೂಸ್ ಗೊತ್ತಬೇಕು. ಸೊ ಆರ್ ಇಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಆರ್ಬಿಟರಿ ಪಾಯಿಂಟ್ ಎಕ್ಸ್ ವೈ ಝೆಡ್. ಸೊ ಯು ಟೇಕ್ ಇಟ್ ಆಸ್ ಎಕ್ಸ್ ಐ ಪ್ಲಸ್ ವೈ ಜೆ ಪ್ಲಸ್ ಝೆಡ್ ಕೆ. ಎ ಇಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಪಾಯಿಂಟ್ ಎ x1 y1 z1. So you take it as x1i plus y1j plus z1k. B is with respect to the point B. So x2i y2j z2k. Next ಈ equation ನಾಗ substitute ಮಾಡಬೇಕು. R value ಇದನ್ನು substitute ಮಾಡಬೇಕು. A value this one, then B value this one. Okay. After substituting, the first step is substitution. After substitution, left hand side as it is you keep. This part you keep it as it is. So ಇಲ್ಲಿ ಏನು modification ಮಾಡಬಹುದು ಅಂದ್ರೆ x2 minus x1, y2 minus y1 and z2 minus z1 you can write it. Okay. Next what you have to do, you have to take this complete term to the left hand side. What it becomes? X minus x1 into I, y minus y1 into j, z minus z1 into k. So this side I have kept it as it is. Next part is just equating I coefficients with I, j with j and k coefficients with k. After equating you get the lambda value as all three are equal to lambda only. So you can equate x minus x1 divided by x2 minus x1 y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1. So this is standard equation of a line passing through two given points in which form? In Cartesian form. So derive an equation of line passing through two given points in Cartesian form. If they ask, you have to derive this equation. Okay. So next what we have is, next we have to see the examples based on these concepts. Once we complete with the examples based on this concept, then we have angle between two lines. But angle between two lines is not there for your syllabus. It is mentioned in the textbook, but ಈಗ reduced syllabus ಆಗೋದಲ್ಲ, ಅದರಲ್ಲಿ angle between two lines, angle between two planes, angle between a line and plane, all these three angles have been deleted. So these three concepts I will explain it in the last session. Okay. Now after this derivation, in the next session I'll be taking up examples based on these two forms. Then we are going to see shortest distance between two lines, distance between two skew lines, distance between parallel lines. Three derivations again we have to see: shortest distance between two lines, distance between two skew lines, and distance between parallel lines. If these three are completed, then we can start with the second exercise 11.2 of three-dimensional geometry. Okay, thank you.